Student of 11th Science, welcome back to division physics classes. Today we discuss about projectile motion, which is actually the motion of an object in a plane. Okay, regarding the projectile motion, we have to know about the definition of projectile motion, condition required for projectile motion, types of projectile motion. Firstly, we discuss about the definition of projectile motion. When an object thrown with an initial velocity into space, thereafter the motion of the object takes place only under the effect of gravity of earth without propelled by any external fuel or engine, then the motion of the object is said to be projectile motion. Means whenever the motion of an object takes place in a plane only under the effect of gravity, then the motion of the object is said to be projectile motion. Here you have to know the object which execute projectile motion is known as projectile, and the path through which the projectile motion takes place is known as trajectory of the projectile motion. Now, for the projectile motion, some assumptions are required. The assumptions are: number 1, there is no air resistance on the projectile. Number 2, the effect due to rotation of earth is negligible. Number 3, the effect due to huge radius of curvature of the earth is negligible. And number 4, throughout the path of projectile, the projectile having a constant acceleration, which is acceleration due to gravity. Okay, now we have to know about the types of projectile. Number 1, projectile given angular projection, and number 2, projectile given horizontal projection. Today we discuss about angular projection. See the diagram very carefully. In the xy plane, from the origin O, we just throw an object with initial velocity u by making an angle theta with the horizontal direction. As we throw the object by making an angle with the horizontal direction, that's why this type of projectile is called the angular projection. According to vector resolution, at the point of throwing, the horizontal component of the velocity is ux equal u cos theta, and the vertical component of the velocity is uy equal u sin theta. First, we have to know the nature of the trajectory, means the nature of the path followed by the projectile during the angular projection. To know about the nature, we consider after time small t, the object reached to the point P having the coordinate x, y. Means in time small t, the horizontal distance covered by the object is x and the vertical distance covered by the object is y. Now see here, therefore horizontal distance covered by the body in time t. Okay, one thing you have to remember here very carefully, throughout the path of projectile, if you consider any point on the path, at every point you remember the horizontal component of the velocity always remain constant, which is u cos theta, because along the horizontal direction no force is acting on the projectile. Clear? So therefore horizontal distance x equals speed into time. What is the speed? U cos theta into t. So therefore t equal x by u cos theta. This is our equation number 1. Now the vertical distance covered by the body in time t. To know about the vertical distance, we use the equation s equal ut plus half at square from the point O to P. Okay, and from O to P, here the object moving vertically upward. So therefore in place of s we write y In place of u, we write u sin theta. Time is t. As the object moving upward, in place of a, we write minus g. That's why this plus becomes minus half g t square. This is our equation number 2. Now, we have to put the value of t from 1 in equation number 2 and say y equal u sin theta, t means x by u cos theta minus half g, t square means x square by u square cos square theta. Therefore, y equal u cancel x, sin by cos means tan theta. So therefore x tan theta minus gx square by 2u square cos square theta. So this is our equation of motion of the projectile. And see the equation 3 very carefully. This equation is comparable with the equation y equal px minus qx square, which is actually the equation of parabola. So therefore we can say, as the motion of projectile obey the parabolic equation, then the nature of the trajectory is parabolic. Nature of the trajectory is parabolic. Now, next student, we have to determine the time of flight, which is denoted by capital T. See the diagram again. The time taken by the projectile to go from O to B is called time of flight. Another way you can say, the time for which the projectile remain in air are also known as the time of flight. Now, to determine the time of flight, we have to use the concept that the net vertical displacement is 0. Why? Because we throw the object from the ground and again after time of flight the object reach to the ground. That's why the vertical displacement during the time of flight is 0. Therefore, using the equation Sy equal uyt plus half ayt square means we write the equation S equal ut plus half at square along the vertical direction. Okay, so along the vertical direction, what is the displacement during time of flight? 0. That's why Sy is 0. Uy is u sin theta. T is time of flight. For vertically upward motion, Ay is minus g. So half g t square. Therefore, from here we can get t equal to u sin theta by g. This is the time of flight, which is the sum of time of ascent and the time of descent. What do you mean by time of ascent? See the diagram. From the point O to A, the projectile move in the upward direction and the time taken by the projectile is called time of ascent. From A to B, the object moving in the downward direction and the time taken to go from A to B is called time of descent. Okay, clear? As the path from O to A and A to B are similar, therefore time of ascent equal time of descent. Clear? You have to remember this. Now, we have to know about maximum height of a projectile. Now see the diagram. Here CA is the maximum height, which is given here by Hn. So we have to determine the value of Hn. Now for the maximum height, we have to take the motion of projectile from O to A, and at the point A, you remember the vertical component of the velocity is 0. We use that concept to determine the maximum height, and taking the motion from O to A, we use the equation Vy square is equal Uy square plus 2Ays. Vy at the point A is 0. Uy means u sin theta. So Uy square means u square sin square theta. Ay is minus g. So therefore minus 2gs is Hm. So therefore Hm equal u square sin square theta by 2g. This is the expression for maximum height. Now we have to determine the horizontal range, which is denoted by r. Now see the diagram. the horizontal distance covered by the projectile from point of throwing to point of again meeting on the ground is called the horizontal range. So therefore OB is our horizontal range, which is denoted by R. To determine the horizontal range, we use the concept horizontal range equal horizontal velocity into the time of flight, because for the horizontal range or for go from O to B, time taken is time of flight, and we already know that along the horizontal direction the velocity always remain constant, that is u cos theta. So therefore range equal horizontal velocity into time of flight. Horizontal velocity is u cos theta and time of flight is 2u sin theta by g. U square 2 sin theta cos theta means sin 2 theta by g. So this is the expression for horizontal range. Now there is a condition for which the horizontal range becomes maximum. When you got the maximum horizontal range, whenever sin 2 theta equal 1 is equal sin 90 degree. Therefore 2 theta equal 90 degree, so theta equal 45 degree. Means if you throw any object by making an angle 45 degree with the horizontal direction, then the object will move maximum horizontal distance, and the maximum horizontal distance is given by the equation R max is equal u square by g. Another two concepts are required for the angular projection. After some time I will provide that two concept also. Student, see this portion very carefully. Thank you.